In this video, we discuss creating frequency distributions. There are actually three kinds of frequency distributions that we will create in our course: just regular frequency distributions, relative frequency distributions, and cumulative frequency distributions. Now, we looked at some properties and terminology associated with frequency distribution in the last learning outcome. For the most part, these are created for us by technology, but creating a few ourselves will help us to better understand what it is we're looking at. This is best done by example, so we're going to use the old faithful data, those eruption times from the last learning outcome video, to construct the frequency distributions. And again, we're going to look at all three types. So we are given this data. We've got 50 numbers here in this table, and we want to make sense of that data. So one way that we can do that is we can create this table called a frequency distribution that will summarize all of the data for us. We're asked to construct a frequency distribution using 6 classes. Now, as we go through this example, I'm going to outline how to construct a frequency distribution for you, and you're going to want to follow the same steps when you do 2 or 3 problems like this, where you're constructing a frequency distribution or a relative frequency distribution or a cumulative frequency distribution in your homework assignment. So the first thing you do is you've got all of your data. We're told to use 6 classes. The first thing you generally do is select the number of classes. The number of classes is generally between 5 and 20. There is a rule involving logarithms that's mentioned in your book, but it's also mentioned in your book that we're not going to use that rule. So I'll just tell you how many classes I want. I would like you to select 6 as the desired number of classes. And then the next step is to collect the class width using the formula below. Now, this is an approximate class width. Basically, you're going to take the minimum or maximum value in your list and subtract the minimum value in your list. That's just the data values. The largest one minus the smallest one, and then divide by the total number of classes that you want. Now, this duration times data for duration times of eruptions of Old Faithful has already been sorted for us, and you've got the smallest number up here in the top left and the largest number in the bottom right. So the maximum is 264 seconds, and the minimum is 125 seconds. So you just subtract those and divide by 6, you get 23.16, and then you're going to round to a convenient number. You always want to round up, so we could have rounded to 24. I chose to round to 25 because I think we're all comfortable with multiples of 25. So you've got the class width. Now you want to choose the first lower class limit, and usually you're going to choose the minimum value or a convenient value below the minimum. So since our class width is 25 and our minimum value is 125, it makes sense to use 125 as our minimum value and then just add 25 a number of times to get the other lower class limits. So our first lower class limit is that minimum of 125. Our class width was 25 from that last example, or not last example, but from step 2 of this example. And then to find the other lower class limits, remember we wanted 6 classes. We're going to take 125 and we're going to keep adding 25 to it 5 times so that we get 6 lower class limits. So we have 125, 150, 175, 200, 225, and 250. And then next we list them in a table. Usually we list them vertically. We list those lower class limits in a table vertically just like this. And then we use the lower class limit of the next class to infer the upper class limit of the one before it. And generally what we do is we just look at that last digit and we subtract 1 from it. So if this is 150, 1 less than that is 149. So we're going to use 149 there. Since this is 175, we're going to use 174 there. Since this is 200, we're going to use 199 there, and so on. And then we use those to populate our table. I also added this title row here. So we've got duration time of each eruption in seconds. And then the next thing we want to do is find the frequency. So that's the number of eruption times in our list of data that have durations between 125 and 149, 150 and 174, 175 and 199, and so on. Okay, so now we want to go through our data and enter a tally mark for each value of, or each data value in the appropriate class, and then add the tally marks at the end to find the frequencies shown in the table. So I've got this first range of duration values, 125 to 149. Now, actually, I need to look at my data in order to create those tally marks. So let's go back to this slide. So I need all of the numbers of data between 125 and 149. And there's only one. So that's one piece of data. So I'd have one tally here, and then I look for all of those between 150 and 174, and all of those between 175 and 199, and all those between 200 and 224. So let's go back to that slide again. Okay, so it looks like 125 to 149 we had one, and then 150 to 174 we have none. 175 to 200 we have none, and then we've got 200 to 225. We've got 220 or 203, 205, 221, and 225. So there's 4 of those. And then you want, so you're going to have 1, a 0, and then you've got 4. And then we want all of those between, or actually it's 3 because it's 200 to 224. So it's 203, 205, and 221. And then the next class starts with 225. So we want to know how many values are between 225 and 250. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and that would be it, 34. And so you keep going through this and you figure out how many data values you have that are in that particular range. And that particular range is called a class. And then after doing all of that counting, you list those frequencies in that right column in your table. And now you have a frequency distribution. Okay, so this is the summary. Sorry, some of the animation is out of order. First, we want to select the number of classes that's usually between 5 and 20. Then you want to calculate the class width by taking the maximum value and subtracting the minimum value and dividing by the number of classes. And then if it's an inconvenient number, if it's 13 or something like that, typically we just round up. Then we choose the value for the lower class limit by either choosing the minimum value or a convenient value below the minimum. Usually we like to have sort of nice round numbers that we're comfortable with, if possible. And then we use that first lower class limit and the class width to come up with the other lower class limits. So you just keep adding the class width until you have the right number of lower class limits. We had 6, so we had to add the class width 5 times to that first lower class limit to get 6 total lower class limits. Then you use the lower class limits that are listed in a vertical column. You use those values to determine the upper class limits. Usually you just take that last digit in the lower class limits and you subtract 1. So if 150 is a lower class limit, then the upper class limit of the class before it is 149. And then you take each individual data value and you put a tally mark in the appropriate class. Ours, tallying data for us was pretty easy because that data was already sorted. If the data wasn't sorted, you could enter it. You could do the data entry in an Excel spreadsheet and then just click sort in Excel and it will sort it from smallest to largest or largest to smallest, depending on what you choose. And once it's sorted, it's really easy to see how many values are within a particular class. So you can sort it first and then find the values that are in that class, or if it's not sorted, you would just have to go through the list and very carefully figure out how many values are in each class. After you've tallied those, then you just write the total number of tallies. So if you found 5 values between 150 and 174, the frequency for that class is 5. Okay, so that is a frequency distribution. A relative frequency distribution is pretty much the same thing. We're just going to change it just a little bit. With a relative frequency distribution, rather than having the frequency in that right column in the table, you're going to have a relative frequency, and that's usually a proportion or a percentage. Your proportion is some number between 0 and 1. Now, the sum of the relative frequencies or percentages should be very close to 100%. Ideally, it would be 100%. If you took the original fractions and added them together, you would get exactly 100%. But if you are looking at the percentages, there's going to be probably, or perhaps there's going to be some rounding error. So it doesn't have to be exactly 100% when you add them together, but it should be very close to 100%. So if you want the relative frequency for a class, all you do is you take the frequency for that class and you divide by the sum of all the frequencies. So if we had 5 values out of 50 that were out of 50 total values, and the sum of the frequencies is the total number of values, right? Then we would just divide those two numbers and that would give us a proportion. You get a fraction, and then usually we use the decimal approximation of that fraction in our relative frequency table, or you can use a simplified fraction, that would work as well. Or you can take that fraction and multiply by 100%, and that's going to give you the percentage relative frequency. So here is our frequency or distribution, the original frequency distribution from that last example. Now we want to make it into a relative frequency distribution. So we add up all the frequencies, and remember what these frequencies represent. These are counts. There is one duration time that is between 125 and 149 seconds. There were no duration times in these ranges in each of these classes, but there turned out to be 3 in the range from 200 to 224 seconds, and 34 in this range, and 12 in that last range. So the total number of data values that we have is actually just the sum of the frequencies. I had 1 over here, I had 3 more here, then I had 34 in a row that were all in that range, and then we had 12 more that were in that last range. So you just do 1 plus 3 plus 34 plus 12, and the sum of the frequencies is 50. So we had 50 data values, and if you want a relative frequency distribution, all you do is take each frequency and divide by 50. Now this notation here might be unfamiliar to you. This is a Greek letter sigma, and this F is what we're using as a stand-in for the frequency, F for frequency. This sigma with the F to the right of that means sum up all of the frequencies. Or in other words, just add all the frequencies together. So when we add these these 6 numbers together, we get 50. So then we take 1 and divide it by 50, 0 and divide by 50, 0 and divide by 50, 30, or 3 and divide by 50, and so on. And then we get these numbers. Now this is the calculation of those numbers. We wouldn't leave our relative frequency distribution in this form, even though that's how we tend to calculate it. We would write it in this form. Or if we wanted these to be percentages rather than proportions, we could multiply each of these numbers by 100%, and 0.02 times 100 is going to give us 2%. Remember, if you're taking a decimal and you're trying to convert to a percentage, you just move that decimal point to the right 2 units. That's the same as multiplying by 100. So this 0.02 is 2%. Of course, that's 0% and 0%. This is 6%. This is 64%, and this last one is 24%. Now, typically, we don't write percentage frequency or relative percentage frequency or percentage relative frequency in the column if it happens to be a percentage. You just understand from context that if they say relative frequency and there's no percent sign, it better be a number between 0 and 1. And you know that you're looking for proportions, or you're looking at proportions. And if you see the percentages, then you obviously, the percent signs, then you obviously know that they're percentages. Okay, so we have frequency distributions, which are just counts. It's a table summarizing counts of things. And then you've got relative frequency distributions, which takes those counts and it divides by the total number of frequencies. Now, see, this relative frequency distribution is pretty insightful. The last one, the frequency distribution, was insightful as well. But with this relative frequency distribution, we can really get a sense of how many data values are within a certain range. We had one data value in this 125 to 149 second range, but that was 2% because we had 50 data values total. But 64% of our eruption times were between 225 and 249 seconds. So that tells us something about sort of a typical eruption time for Old Faithful. And we have this very low one, that one eruption time that was between 125 and 149. That might not be as representative of what Old Faithful typically does, although obviously it can happen sometimes because it happened at least once. Now, the last type of frequency distribution we want to construct is called a cumulative frequency distribution. All you do is add up the frequencies from a particular class and all of the classes before it. So this is my frequency distribution. I've sort of condensed it. I've made it like tall and skinny so that I have more room on my slide. To get the cumulative frequencies, you just add. So in that first class, you just write a 1. And for the second class, the cumulative frequency is the 1 plus the 0. So you get 1 again. And for the third class, it's the 1 plus the 0 plus the 0. And the fourth, you add the 1, the 0, and the 3, and so on, and you go throughout the table. Now that last cumulative frequency should be the total number of data values that you had in your data set. So we had 50 values. So that last cumulative frequency is 50, which is as it should be. At that point, all of the frequencies or all of the eruption times are accounted for, or duration times of eruptions are accounted for. Now we wouldn't typically write it like this. We would typically write it like this. Now, if the duration time is less than 150 seconds, so that's any durations between 125 and 149, if you're looking for how many of those duration times were less than 150 or 150 seconds, it turns out there was only 1. And then in this class, now instead of having eruption times within this range, now you're looking at all of the eruption times in this range and the range before it. So you're looking for all of the durations of eruptions that were less than 175 seconds. And since there were none in that second class, there's only 1. And then we did the same thing for the next class and the same thing for the next class. And so if you look at this less than 250, you're saying how many of those duration times for eruptions were less than 250 seconds long. And it turned out that in our data set of 50 values, 38 of those were less than 250 seconds long. So that's it for relative frequency distributions, cumulative frequency distributions, and frequency distributions. I'll see you in the next video.